Hey everybody. In class lately we've been spending a lot of time working with integers, understanding what they mean, how to compare them, adding, subtracting. But as we move along in this class, we're going to spend some more time actually applying these concepts to real-world situations. And in order to do that, today we're going to take a look at a strategy that helps us analyze those situations, break them down, and make them easier to figure out. And this strategy is called STAR. So each letter in STAR stands for a different step in the process. The S stands for study the problem. When we're studying the problem, we're looking for the important information, and we're also trying to identify what information we don't need to solve the problem. So we're always going to underline the question. That's the most important part of the problem. What are we actually being asked to find? Then we want to put a box around the important information to highlight the actual stuff we're going to need, and then we can cross out everything we don't need. Get that out of the way so it doesn't distract us with meaningless information. The next step is to translate. We're going to turn the problem into a mathematical statement or a picture, something that helps us understand it better and something that can move us towards solving it. Once we've translated it and we have it written as a mathematical statement or a picture, then we're actually going to take some steps to solve the problem. That's what the A stands for. We're looking for the answer. And then after we find the answer, we've taken our steps, we're going to review it. We're going to go back to the question and make sure that the answer answers the question that we underlined and that it makes sense within the context. We have the unit right, the size of the number makes sense, and then we're done. All right, let's take a look at a couple examples to see how this actually looks when we're solving problems. If you want to, you can pause the video here so you have time to write down the example. That way when you look back at your notes, you'll actually be able to see what you were doing. All right, ready? Our example says the highest point in California is Mount Whitney at 14,494 feet above sea level. The lowest point is in Death Valley, which is 282 feet below sea level. They are 109 miles apart. What is the difference in elevation between the two? So I'm going to start by writing my acronym over here on the right so I can remember my steps. So the first thing I want to do is the S step, study the problem. Remember, the first step for S is to underline the question or what we're trying to find. So this says, what is the difference in elevation between the two points? My next step is to box the important information. So Mount Whitney is at 14,494 feet above sea level. This is going to be sort of a continuing, a wraparound box here. So I want to make sure that I have above sea level. That's going to be important. And our next important piece of information is Death Valley. Put another box around that because that is at 282 feet below sea level. I got to do another wraparound box. It doesn't look pretty, but it gets the important information in there. Now I want to cross out the information I don't need. So I'm looking at the difference in elevation. I need to know their heights, but I don't need to know the distance between them. So I'm going to take this out of the problem completely. You know what? I'm also going to cross out the highest point in California because I can see that in the height already. I don't need those extra words. I'm going to take out the lowest point because I don't need those words. I already have the elevations. Okay, so now I only have two pieces of information and I have my question, and this makes it a lot easier to understand. So S is done, and now we're moving on to T, which is translate. Now there's a couple different ways I could look at this. I could draw a picture, right? I could draw Mount Whitney and then Death Valley. So Death Valley might look, something like that. And I know their height's in relation to sea level, so I'm going to draw a line that represents sea level. Okay? So now I can label their heights. Mount Whitney is 14,494. That should be a comma, not a decimal. And label the unit, feet. And Death Valley is 282 feet below sea level. Because it's below sea level, I'm going to use a negative sign to represent that. So there's my picture. I can also write this as a math statement. It says, what is the difference in elevation between the two? So my math statement, if I'm looking for difference, difference means subtraction, 14,494 minus, we're going to subtract 282. So that represents the difference between the 2 points. Now, we're done with our t-step, we're done with translating, now we can look for our answer. So I want to solve this problem. I have a subtraction problem, I'm subtracting integers. I could do the counter method, but that would be a lot of counters, 14,000 counters. I don't want to take the time to draw that. So instead, what I'm going to do is I'm going to turn this into an addition problem, right? I can turn this into an addition problem by writing it. My first number stays the same. My second number, after I turn it to addition, is going to change sign. So it was negative. I'm going to change it to positive. So this is the new problem I'm going to solve. So I have 14,494. I'm going to add 282. Make sure I line up my place values. And I'm going to add it up. I got 6, I got 17, I got 7, 4, 1. So my answer is 14,776 feet. I'm going to put a box around that. But before I finished A, I need to go back and review. Does my answer actually answer the question that was asked? What is the difference in elevation? Right? Feet is a measure of elevation. It's a measure of distance. So the unit works. And our number makes sense for this problem. It's not too big. If it was 30,000, maybe we would need to rethink this. It's not too small. If we got 57, maybe that would raise a red flag. But this number looks pretty good, and I think we can be done with this problem. Review is done, and we are done. I said we were going to have a couple examples, but I think if you took really good notes on this one and you were really paying attention, I think we should be good, and we can end there for the day. And I will see you guys on Monday.